Tā, es redzu, ka mēs esam 9 cilvēki pašlaik. Jūs varat ierakstīt čatā, vai jūs mani dzirdat, vai viss ir, tad ierakstiet lūdzu čatā, vai jūs mani dzirdat, un vai audio ir labi un video ir labi. Varam ierakstīt plusiņu, mīnusu, kaut kādu informāciju, lai es zinu, vai šis strādā. Vai viss ir dzirdams un redzams? Vēl pagaidīsim arī kādas minūtes, lai pievienojās vēl citi cilvēki. Ļoti labi, ļoti labi. Mums vajadzētu būt mazliet vairāk cilvēkiem, bet būs arī pieejams video vēlāk. Vienkārši būs grūtāk būs izsekot, ja tagad nepievienosimies laivā šiem te workshopiem. Tā, pagaidīsim vēl pāris minūtes un tad sāksim. Būs diezgan intensīvs darbs, tāpēc sagatavojiet jau darbu vidi. Es īstenībā vēl vienu rīku, ja jums iedošu, tad kamēr es meklēju tos rīkus, ierakstiet varbūt kādu operētāju sistēmu jūs izmantojat. Tā. Stop, kas te man tur sanāca? Tā. Ierakstiet, vai tas ir Mac, Windows, Linux. Vienkārši kāpēc to jautāju, jo mēs kodēsim, kamēr notiks workshops, un ir daži rīki, kas atvieglo dzīvi mazliet. Tad ierakstiet to lūdzu. Es tomēr mēģināšu atrast, lai es vienkārši gribu zināt, vai kādi jums ir. Tad Windows ir, tā kā teiksim, sliktākais variants, bet ja jums ir, tad dzīvosim ar to. Un top replika. Ok. Labi, es varbūt pasāstīšu, tad vēl pirms mēs sākam. Tātad programmas, lai būtu ērtāk sekot līdzi kodam. Viens ir, man liekas, ka Chromam ir picture-in-picture funkcija un arī Firefoxam. Tad vēl eksistē tāda on-top replika. Ja kāds īstenībā zina līdzīgus rīkus, tad varat ierakstīt čatā, lai es varu nošērot savu on-top replika. Ir uz Windows, lai parādīšu arī, kā tas izskatās. Tad uz Maca ir Gitā var atrast picture-in-picture, GitHub. Un uz Linux ir, man liekas, labākais, kas ir piemēram, uz Ubuntu vai tam līdzīgiem, vienalga kāds distro, būs Firefox, ir arī picture-in-picture režīms. Tā galvenā doma šim, ko es mēģinu pateikt, ir, ka ir vēlams pieinstalēt jums ātri kādu rīku, vai arī, ja jums jau ir tādu, lai jūs varat noklonēt, noklonēt to video, kas iet pašlaik laivā, uzlikt kā mazāku izmēru lodziņu, kas stāv pa virsu jums uz ekrāna, un tad jūs varat operēt ar to, tā pagastulīt. Tu varat sekot kodam labāk līdzi. Mēģināšu atrast kaut kādu piemēru. Video. Kādu screenshotu. Copy image. Es nezinu, cik vienkārši paņēmu kaut kādu random screenshot no interneta, bet tā ideja ir, ka rekur ir tāds lodziņš, ko jūs varat noklonēt to video, kas ir, vai arī picture-in-picture, viņu pievilkt, zoomot tieši to daļu, kur ir kods, piemēram, un tikmēr rakstīt otrā daļā kodu vai sakot līdz uzdevumiem. Tikai tas ļoti noteikti atvieglotu darbu. Tas atvieglotu darbu. Tikai pamēģiniet to uzstādīties. Ja kāds zina labāks rīks par šiem, kurus es nošēroju, tad dodiet man ziņu. Mēs esam 14 ļoti labi, tā kā gandrīz vai visi ir pieslēgušies. If somebody doesn't understand Latvian language, then please type in the chat so I know. We'll think what we can do. But pēc būtības mums vajadzētu šo te vadīt latviešu valodā. Tātad mēs sāksim ar prezentāciju. Tad mēs vēl parādīšu plānu. Un tad mēs sāksim kodēt diezgan intensīvi jau šodien. Tāpēc mēģiniet, es nezinu, mēs pienāksim līdz tam brīdim, ja jums nebūs gatava video uz kā kodēt, tad vienkārši jūs nāksies kodēt online. Ja jums ir 2 monitori, tas ir vislabākais. tas taisnība. Vai arī 2 monitori ir ideāli. Jā, bet ne jau visiem ir 2 monitori, bet ja ir, tad tas, protams, ir ideāli. Labs punkts. Tā, ok. Tad pārējām pie prezentācijas, lai jūs bišķi saprotat backgroundu visam šim. Tā. Esmu Evalds Urtēns, doktorantūras kandidāts, priekšaizstāvējies, cerams, ka dabūšu to grādu diezgan drīz. Tad vēl man ir tāda websites YellowRobot.XYZ, tur apmēram kaut kāds daudz gadus, kādi 10 projekti, visādi open source uzbūvējis esmu. Tā kā pats savu siltumsūkni, tur visu elektroniku, visu uzbūvējis robotus, kur man tāds maziņš robots, kas seko augiem līdzi. Viņš runā miņonu balsī, ko man sievi ierunāja. Tad robots, kas bērniem māca vārdiņus, stāv braukā pa telpu. Visādi tam līdzīgi interesanti izgudrojumi. Tikai jūs tiečakot to saiti, YellowRobot.XYZ, visādos creator portālos var atrast. Tad, ja jums interesēs viss tas deep learning virziens, tad eksistē arī Data Science Latvija, gan Facebookā, gan LinkedInā. Mums katru nedēļu ir diezgan advancēti workshopi un pētījumu lasīšana. Tur piedalās no Lumi, EDI, RTU, dažādiem uzņēmumiem, kā The Dots, Skolio, protams, Giraffe, diezgan daudz visādi uzņēmumu pārstāvēti. Mēs veicam pētījumus, mums ir caur RTU arī pieejami superdatoru resursi, daudz GPU. Arī Ventspils augstskola mums piešķīra šim kursam arī diezgan labu GPU aprīkojumu bāzi. Daļa no jums jau saņēma pieejas, ja vajadzēs pieejas, vēl atsūtīsim. Ja ir kādi jautājumi, kamēr es šo visu stāstu, lūdzu rakstiet čatā, un es labprāt atbildēšu. Tad šie būtībā mazliet par mākslīgo intelektu. Šīs bildītes ir no Isāka Azimova. Iečakošu mazliet. To mēs varam ierakstīt vienkārši, kur no jums ir lasījuši Isāka Azimovu. Kuri ir lasījuši Isāka Azimovu un ko tieši? Varat ierakstīt čatā plus, mīnus, ja nāc vispār lasījuši, ja var nosaukt kaut ko foršu. Es tomēr ātri iečakošu precīzāk gadus, kad viņš tās grāmatas rakstīja. Tāpēc, ka man liekas, tas bija diezgan sen apakaļ. Un, 50, 40, 50 gadi. 40, tad ir vairāki tādi zinātniskās fantastikas autori, kas ir diezgan spēcīgi, kurus būtu vērts arī mūsdienās paskatīties. Isāks Azimovs, tad īstenībā tādi mazliet distopiski, kas ļoti sinhronizējās ar mūsdienas trākumu. Aldous Huxley, to Brave New World un vēl citi. Tikai iesaku visu kaut ko tādu apskatīties. Bet tātad īsumā viņš 40. gados aprakstīja to visus būtībā mūsdienu zinātnisko fantastiku filmu plotus. tā kā stāstus. Tur bija viss, sākot ar to, ka roboti, kas pieskat bērnus, tur roboti, kuri paņem cilvēku darbus, viņi visiem ir tā kā tās pozitroniskās smadzenes, kas diezgan precīzi, diezgan saskan salīdzinoši ar to deep learning virzienu. Protams, tur tas tika iekļauts iekšā kā tie robotikas likumi un vēl kaut kas nav precīzi kā deep learning. Bet, tā kā es domāju par mākslīgo intelektu, es domāju par šādām mašīnām vairāk nekā par kaut kādām specializētām, pavisam ierobežotām mašīnām. Tikai, ja jūs neesat šo visu lasījuši, redzu, ka jūs neesat, iesaku iečekot. Un arī ap tiem 40, 50, 60 gadiem tika vairākas fundamentālas Arthur C. Clarke, Isaac Asimov, Aldous Huxley, protams, arī George Orwell. Tie divi pēdējie distopiski. Tā kā, labi, nākamais jautājums. Šo te ilustrāciju jūs atradat Facebookā pirms kāda laika. Es ceru, ka jūs vismaz zināt, kas ir Scooby-Doo. Labi, es zinu, ka šie jautājumi ir dūmiņi, bet whatever. Tā, jūs zināt, kas ir Scooby-Doo? Vai zināt, kas ir Scooby-Doo? Ja jūs nezināt, tad čakrīgāk. Plus, mīnus īstenībā. Jā, savu šitā var atbildēt. Es apsolu, ka paliks drīz aizvien matemātiskāk un zinātniskāk, un tad jūs varbūt nezināsiet, tāpēc labāk varbūt izbaudēt to laiku, kamēr es vēl jautāju muļķīgs jautājums. Gaidu atbildes, plus, mīnus. Ok, es pieņemu, ka varbūt jūs nezināt, kas ir Scooby-Doo. Ok, forši. Vismaz daži zina. Pagaidīsim vēl, lai visi nosinkronizējās YouTube'ā. Tāpēc, ka laikam kādiem ir mazliet delays. Bet tas fine. Varam pagaidīt. Ok, tad tikmēr var iedziļināties jau šajā bildītē. Tad bildītē Scooby-Doo ir tā, ka viņi tur dodās ar savu to komandu un visādas briesmoņas noķer. Un tiem briesmoņiem parasti, ka viņiem noņem masku, izrādās, ka tie ir parasti cilvēki. Tie nekad nav tādi īsti briesmoņi. Un šeit ir kāds sagatavojis tādu mīmi, kur ir tā kā noķerts briesmonis, Sofija, tas intelektuālais robots, vai ne? Un apakšā ir rakstīts, hei, mēs noķērām Advanced AI. Un tad tas tur noņem nost viņam masku, un apakšā tur ir pilns ar if statementiem, pilns ar likumiem. Un tad, tā kā, kad tas briesmonis, mākslīgais intelekts un bez nav nemaz tāds briesmonis, tur apakšā ir daudz likumu. Un tad mans jautājums ir, vai tu piekrīti, ka tas ir mūsdienu būtīgi, teiksim, mūsdienu AI. Tā kā plus, mīnus. Vai tu piekrīti vai nepiekrīti pēc šīs te mīmas, kad būtībā mākslīgais intelekts apakšā ir vienkārši ļoti daudz likumi, un būtībā tad tu var iegūt tādu inteliģentu būtni. Pagad šim jautājumam gan es gribētu, kad visi atbild, ja ir iespējams, ja jūs varat aizsniegt klaviatūru un iepostēt kaut ko čatā, es būtu par to priecīgs. Ja tie, kas postē mīnus zīmes, varbūt ierakstiet, vai ierakstiet, kas tad jūs prāt ir mākslīgais intelekts, ja jūs sakat mīnus zīme. Tāds mūsdienu izpildījumā saistībā ar deep learning. Labprāt, priecātos par kaut kādu paskaidrojumu pa mīnus zīmēm arī. Tā es tagad redzu pēc rezultātiem pagaidām, ka mums ir 1, 2, 3, 4 pluszīmes, 1, 2, 3 mīnuszīmes un 4 mīnuszīmes, un vēl ir vesela kaudze, kur nav atbildējuši. Un tie, kas postē mīnuszīmes, ierakstiet, tad ja jūs domājat, ka ir mīnuszīme, tad kas tad ir īsti? Tad tas deep learning, kāpēc tad tas nav? Forši. Armāns vismaz ierakstīja vienu virzienu. Es vēl pagaidīšu kādu brīdi. Es redzu, ka visi nav iepustējuši. Gribētu tomēr, ka mēs interaktējam vairāk ar šo čatu. Jā, es vēlreiz mēs iziesim arī saturam cauri, bet jo jūs mazāk paši interaktēsiet ar mani čatā, jums pašiem būs grūtāk, jo drīz paliks aizvien smagāks tas kurs. Šitais ir reāli tāda izklaides sākums. Nu labi, vēl kāds atbildēs? Pagaidīsim vēl kādu minūti. Cik mums ir vispār tie, kas ir iesaistījušies? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, bet mēs esam 16 online. So, kāds nav iesaistījies? Ne par ko negrib iesaistīties. Nu labi, virzamies priekš, mums vienkārši nav laiks, bet žēl, kad kāds negrib iesaistīties. Tad Armāns, kurš atbildēja cēlu mēt, tā pilnīgi taisnība. Tad mūsdienu deep learning mākslīgie intelektu modeļi nesatur tādā klasiskā izpratnē nevienu likumu, tā kā neviens if statements whatsoever. Viss ir tikai funkcijas un mācām parametri. Un funkcijas nevis kā programmēšanas funkcijas, bet kā matemātikas funkcijas, kā jums mācīja algebrā un ģeometrijā. Tā kā šeit ir viens neliels modelis iedots, bet nav svarīgi kas, bet kaut kā, man liekas, šitais ir kaut kāda RNN šūna, varbūt ar kaut kādu attention mehānismu. Tā kā tā. Tad līdz šim man ir bijis tāda iespēja strādāt ar daudziem visādiem zinātniekiem un pašiem dabūjuši visādas balvas esam. Tā kā jūs pievienojaties tam, ko mēs darām, pastāv iespēja, ka jūs arī varat dabūt balvas. Es pats ar savu doktorantūras darbu pētu dažādas jaunas kļūdas funkcijas, ja mērķa funkcijas. Jā, un tur tā pamatojums ir tāds, ka daudzas funkcijas, kuras pašlaik pēdējos gados ir atklātas, nenāk no informācijas teorijas izvedumiem vai no jebkuras varbūtību teorijas izvedumiem, bet viņas tiek iegūtas empiriskā ceļā, un mēs arī diezgan daudz interesantas funkcijas esam iegūši empiriskā ceļā, kas pārspēj tās, kuras ir izvestas. Tad rīkus, kurus mēs lietosim šā kursa ietvaros, būs PyTorch primāri. PyTorch šis ir vēl diezgan vecs, 2019. gads, bet ir tagad pilnībā dominē TensorFlow un vispār zinātniskajā laukā, jebkādas deep learning bibliotēkas. Viņi ir ļoti funkcionāli bagāti, sākot ar to, ka to rakstīt matricu vektoru vienādojums, ko mēs darīsim līdz tam, ka tev ir ļoti daudz, kas jau gatavs atšķirībā no citiem rīkiem. Un tu vari debagot funkciju grafus pašā vidū, nevis kā TensorFlowā viņus kompilēt, un eager execution vēl joprojām strādā slikti. Tā kā, tad mums ir dažādi citi pētījumi. Šeit ātri pārskriešu pār dažiem. Mēs nopublicējām tādus modeļus, kas var iemācīties klasiskus algoritmus, karšu plānošanas, kas strādā par kārtu ātrāk nekā klasiskie algoritmi. Tad visādi denoiser modeļi, kas ir tā kā, ka tev fonā ir troksnis, NVIDIA RTX voice, kad pazūd fonā, ka kaut kas bļaustās, to mēs izmantojam vienā no mūsu produktiem ASIA. Tad Deep Reinforcement Learning. Mēs iemācījām uz superdatoru spēlēt dažādas spēles. Piemēram, Flappy Bird viņš spēlē mūžīgi. Mēs arī mūsu modeļos mēģinām viņus pārvērst par whitebox. Mēs varam pateikt, kāpēc aģents izdarīja kaut kādu lēmumu konkrētā brīdī, tā kā kreisā pusē pirms trenēšanās, labā pusē pēc trenēšanās. Un interesanti, ka mēs atradām, piemēram, šajā spēlē arī bugu, ka tas putniņš varēja pārlidot pāri augšējai caurulē, tā bija reimplementācija tam Flappy Bird spēlē. Un tieši tas, kad mēs varējām apstīties, ko tas modelis domā, izmantojot, manipulējot ar vidi, tad varēja viegli atrast, kur bija problēma. Ja mēs visādi sarežģītākas spēles, tur 3D spēles, mini-spēles dūmas, kur tā kā jāizvairās no uzbrukumiem, pašam jāšauj. Un tam līdzīgas modeļus arī izmantojam. Okay, speak in English. Let's think. So let's do a small survey. let's do a small survey. So are you okay if we do this in English? Vai jums ir okay, ja mēs runājam angliski? Tāpēc, ka šeit daļa no jums maksā par šo apmācību, ir dažādās universitātēs iesaistīti, tad man ir vajadzīgs piekrišana, teiksim, gandrīz vai no visiem. Ja kāds saka nē, tad mēs tomēr nevaram tagad to darīt angliski. So here are a lot of students who are paying for education, so we need to double check if we can do this in English. So we'll see if somebody objects, then we probably cannot really do this in English, but hopefully we could. So far everybody says that's okay. Really hope that we could do this, because in general, some of the terms that we're going to use, they are quite English specific, and it would be quite hard actually to translate all of the deep learning terms. So now, so far nobody objects. I hope that if somebody objects, then let me know later. And because I know that at least in Ventspils University, I should speak in Latvian, but if everybody is okay with English, then that's great. So, okay, then we also have, I'm just showing some of the research that we're doing with the teams that I lead. So right now I actually lead around 20 researchers in different directions in multiple universities. And I think like at least last check 3 or 4 universities. Here there's like a maze task where you need to find exit in the maze. And this is also we used as a white boxes, so we know where the agent is focusing on. And we also increase the task difficulty step by step. So just showing some of the research that we're doing, hopefully that could inspire you of what you could do, or you could do even something more interesting. I don't have time to show everything. So here there's another model where we do the curiosity learning. We try to simulate human curiosity because the mazes are quite big and you need to find the exit from the maze, and the reward signal is very sparse. So using this kind of curiosity modeling, where we try to kind of have intrinsic reward system that helps the agent move forward. And then the fun thing is that if we put, so it's actually the one problem that we overpassed, is that if we put the a TV inside the labyrinth, the agent just stops and watches TV forever and fulfills the curiosity and don't do anything else. So that was kind of funny because I have 2 small children and they do the exactly same thing. So that it was really interesting that you can simulate in deep learning the behavior that actually is the real also in the biological agents. So sorry. So here there is also some other research that we got actually award in a conference last year. So this is a zero-shot voice ID, similar like in the Face ID, Apple Face ID, where you train model once and then you introduce new classes in the model and you don't need to retrain it at all. So this is a deep metric learning basically. So here's again some interesting example. There's letters during the training. They have been seen only during the training. At the inference phase, the testing phase, we give the model completely new letters, and they are grouped in the clusters by the similarity, like without any like training, you know. So that would be zero-shot learning. So there's quite cool models that you could work with. We tried all sorts of loss functions there, really interesting ones. You can use that also, of course, for face identification. Here's a fun example. I applied that model for the Simpsons. So these are some of the Simpsons that were in the testing set. So I split Simpsons in training set and testing set, different classes. And you can see, like, I think funny that Lisa and Sideshow Bob with the hairstyle, they are similar place, and then the car is up here, he is very different from others, and then the boys are down there, and so on the other side. So that's also a fun thing. So I mean, these deep learning models are fun. So and I think the last kind of interesting direction that we're doing quite intensively, a lot of researchers of mine are working on these projects. We are doing emotion classification from biometrics, starting from face, video, audio alone, the heart rate, the facial segmentation, all sorts of crazy things. So, and also we data mined the YouTube and all sorts of public domain videos. So just a fun fact that we found the most expressive emotions for the men from the sports game interviews, where they usually don't express that much emotion in other types of videos. Yeah, and we got state-of-the-art classification accuracy. We are right now in the process of publishing that, and we also are building an B2C application that's not really specifically for students. It's more for the young parents, but maybe some of you are. So anyways, this is a really interesting tool where we combine the emotional part, the conversational part, the psychological part, and the NLP, natural language processing, with about 6,000 topics, and give experience where the conversations help to improve relationship. Okay, so that's about this. So let's move back to the project. So first of all, we have the I asked you to prepare the environment, and also to be able to work with the Hello World example. So I will quickly drop in the Hello World example also here probably. But okay, while I'm doing that, let me know that is the Hello World working for you? So I will share my screen as well. It's funny because the Hello World example was the only example that I did not prepare in ahead, because I was thinking that that's not so important. Okay, now I got it. Just a second. I have all of the other samples ready, just this one. Okay, so yeah, I got it. So I will share the screen, and I will type in the question in a second. So, is the Hello World working? So I post that in the Google Classroom, but for those of you joining without the Google Classroom, I will also post that in the chat just in a second. So where is the screen? Okay, so here there is. So I suggest that you use the PyCharm, this edition. So the PyCharm, if I share the whole screen, just a second, file, PyCharm, right? So you can get that from the student version for free. So if the Hello World is not working for you, then then you have two options. So first, hopefully you can get Hello World from the link that I will just post in a second. The other thing is that then you probably need to use some different kind of environment, because the PyCharm will take time for you to set up. So I suggest that then, if you're not ready to work right now, then you should use the Google Colab. I will show you that in a second, but let's wait for everybody to answer the question, is the Hello World working? So we'll see how many minuses do we get. Just a second. I need to set up my ability to share the documents. It might take actually some while, so meanwhile, we'll try to share it to the Google Drive probably. That will be quicker. That will be hopefully quicker. Meanwhile, while we are waiting for the pluses or minuses, because we're going to start quite quickly with the Python basics, and afterwards, at the end of this session, we'll have like something in a direction of a computer game ready. That will be because we want to learn about the linear algebra using the computer game, basically, and that's a requirement for deep learning, and we want to make it fun. So the file, so here I dropped in the Google Drive file, so this will be the YellowRobot.XYZ. You can get it here. So for tomorrow we also have this workshop. For tomorrow, you definitely have to get this thing going on. So like the PyCharm is working for you, or maybe you want to use this, what was the name? Microsoft, some kind of code stuff that they do. So if you use that, the Microsoft IDE or whatever, so you should set up that as well. So here, if I run this one, I get it running like this. Let me see. Okay, and it says that hello world, all libraries are loaded. If they are not loaded, then you probably need to press down here with the Python console, no, with the terminal, right? And in the terminal, you can install these missing libraries, like, for example, pip install matplotlib, or conda install pytorch, or whatever. So that's all written actually in the documentation, but those of you who say that they are not yet ready, but we must be ready now, that's why you should use the Google Colab. I will show you that one as well in a second. Google Colab is a free Python environment in online that you can even access the GPUs and TPUs, so that's really cool. And we're going to use that probably multiple times during this course. And this is also a way quick fix for your problem with the Hello World. So it's still loading for me now. Just a second. So the way how you get in the Google Colab is following. So you go in you type in Google Colab in the Google, right? So this is called Google Colab, right? Then you get this new project, you get this environment going on here. One thing cool that you can do is change runtime with the GPU, but that's not needed right now. So what I want from you, those of you who posted minus, I want you to do this, copy the code from the Python inside here and run it here with this button. So if you run it here, it should work, hopefully, because I think you don't even need to install any libraries here. And if you want those cats going on top of this window, you can enable them with tools, somewhere options, whatever. So anyways, do this, please. We need to get this ready. So meanwhile, those of you who done this already, I will start by just briefly giving you a plan. So maybe I will have to later translate the plan in English, but for now we'll try to do semi-English. So some parts. So if everybody is okay with English, I will jump to the English later. So maybe I can also change this to the workshop. Okay, so cool. So the course plan, it's gonna be done in the Google Classroom. So if you want to join Google Classroom, please write to me. So maybe I will drop in my email. So if you want to join the course to the Google Classroom to take the whole advantage of everything that we do, so you should write evals urtans@edu RTU like that. So and then I can join you to the course. But the plan is following. So we're gonna make the we're gonna start by Python basics and NumPy basics, and we're going to implement Asteroid Game and learn the linear algebra. By linear algebra, I mean the matrix multiplications, all sorts of them, dot products, maybe cross products, linear transformations, all sorts of them. And then we're going to move to the NumPy, and we do in the NumPy the partial derivatives, the sum of the differential kind of equations, the optimization procedures, and we're going to learn all of the math part directly in NumPy in pretty low level. We're going to do in low level the regression tasks and the classification tasks. And then we're going to jump to the higher level of the PyTorch with the classification tasks, and then, okay, this one should be PyTorch, then jump back also with the regression tasks to the PyTorch. Then afterwards we're going to have the convolutional neural networks. Those not going to be a lot because there's another course doing those things. Mainly we will try to implement the kernel functions. Then then there's going to be the tensor board and some data analytics stuff. Then later we will have something in the direction of the deep metric learning, but more in a way of autoencoders and variational autoencoders, the generative models, then time series, RNN, LSTMs, and attention-based models, transformers, and at the end a little bit of the deep reinforcement learning that I showed you about the games. So if you have any questions about the material or the stuff that we're going to do, you can also write that in the chat. I will also quickly show you the the game that we're going to do, the Asteroid Game. So the Asteroid Game is this one. So hopefully you have seen this somewhere. Like this is like really old game based on vectors, and we're gonna implement this game a very basic way with Python and with matplotlib. So that's like plotting library, and you can see that every point in this graphics, they are actually vectors, right? And you can have like described by vectors this asteroid or this like a ship player, and you can do all sorts of linear transformations with those vectors. So this is what we're gonna do. And because the deep learning stuff is also all about like a lot of that is about the transformations of one kind of vector to another kind of vector, this will be quite useful for us. Okay, so that's about this thing. So we need to move on because otherwise we don't have enough time today. So I will go back to the code. So just a reminder, I really highly recommend to have these software installed so that you would have your screen as a small window and you can do the coding beside it in the real time, and two monitors would be, two displays would be ideal. Okay, so let's do that. So I go back to the code, and today I repeat will be like just a very intro, and we will get very fast to the more complicated stuff. So I have the hello world here running. We will go over a few things. So first of all, if this is not working for you with the PyCharm, then you need to read up how to make it work. And right now, in order to work with us in live session, then you need to use Google Colab. So I will write down. So if this is not working for you, please use Google Colab and fix ID later. We cannot waste time, basically. So first command that you see, that is print command. So the print command allows us to print out all sorts of things, right? So, and if I add this hashtag, it means a comment in the Python. So the hashtags are the comments, right? Then the next thing, I will also keep a watch on the chat, so please ask if you have some questions. So the next thing is going to be the variables. So variables. So we have option of very simple variables. So the Python is not strongly typed language. So weak type, I'm not sure, like language. So what I mean by that is following. Is that I can have some variable one that I set as a string. So hello, like that. So this is a string. Also, you can have in the Python with quotes with the two, like the small quote or the big quote, both works. No difference. So this is the same. So, but with a weak typed language, I mean the following: that I can have this variable one changed to some integer value 5, and it will still work. There is not going to be error. So there is no assignment of the type to the specific variable. So what I mean by that is that some languages like C, C++, C Sharp, whatever, like a lot of languages that you probably compile, they require to have some predefined type. This one doesn't require the predefined type, so this is similar to JavaScript. So we have the strings. So this is a strings. We have the integers, like that, right? Then we have the floats. So variable, let's say this is going to be 3. This is going to be the floating point numbers. Of course, we can write it like that, let's say, or we can write it in a much nicer manner, is like 1, e minus 2. So this is like basically the same thing, just written in two different ways. So like that. Then I suggest that you write these things in your code right now as well. And if you try to run it, it should not produce errors. If it produces errors, then something is not okay. So if you run it, it says that exited with 0 code. If it exits with something red, then this is not okay. So if you have some questions or something, you can maybe drop the code in some paste bin, or do the screenshot or something else, or just type in the chat so I can help you out. So these are the types. Then like common type is also, of course, Boolean, right? So false or true. This is written with the capital letter. So with cap letter, right? So this is going to be that one. And then we have the some specific types. So one of the specific types that we have is regarding the collections. So let's see. So lists. So this is going to be we can call it like variable 6. This is going to be the list. So the lists are written with these square brackets, like that. So these are the lists. And we can define list contents, like what is inside the list, or you can call it array or whatever. So the contents of this can be also defined at initialization phase. So we can write 1, 2, 3 or whatever. We can also have lists within the lists, right? So we can have it not uniform. Like for example, here inside this one, we can have sub list or something. And this is going to be variable 8. And we have all sorts of functions that we can use, you know, like we can, for example, add something like append. So again, I will show you why the PyCharm is good and something like that is good. So if I write here append, it will give me autocomplete. So like IntelliSense or like whatever, how they call it. So You can have autocomplete, and that is useful, especially if you don't know the language well. So if you use the code in the Google Colab, you might not get all the autocompletes. If you use this in the PyCharm or some other environment, it's really useful that you start writing stuff and it will give you the suggestions. So for example here, we can also have index. So the index means finding the index at which there is specific value. So for example, this one, so this will be the index IDX of 2. So here, let's just double check that you follow. So what do you think, what's going to be the value of IDX2? So what will be the value of IDX2? So if you don't know the answer, you can try to code this stuff and then write print IDX2, or you can also use the print of like with this F letter. So this is a formatted string, and have IDX2, and with these kind of curly brackets get the output encoded in the string. So my chat question is in the chat. Meanwhile, while you answer my question, like I suspect that people who are familiar with programming should look at the line 27 and could immediately write the answer in the chat without the running the code. So I see one answer in the chat. That's great. I want to see more answers. So meanwhile, I will add this stuff to the Jamboard. So as just like somebody who, like if somebody has struggled to getting along this, you will have this in the fourth slide, this code, and we will slowly move forward. So I see two answers. I think one is, so some are from, one is from RTU, two guys from Ventspils University. So we have a little competition going on. So I see more answers. That's great. Hopefully you write those answers just looking at the code. So that would be great. So I like that. I will not tell the correct answer, but I like that you have some opinion that is in the same way. So anyway, so we have these functions. Then one very funny function that is not like normally done in this Pythonic way is that there is delete function. So delete means removing some element. So if I write down delete and var, so let's see, var 7, let's use the var 7 again. So delete this one, and let's delete element number 2. So, okay, so this was my previous question, right? So my next question is going to be, after this line, what do you think, what will be the contents of var 7? So maybe type in the chat the contents of var 7. So if you are super comfortable with Python, maybe I should have asked that question as well. After this one, I will ask that one. So here you can also write it in this way, and it will just print out the variable 7. So let me know, what do you think will be the output after that command? And we will look briefly at a few other commands, and then we'll have some task going on. Meanwhile, while I wait for answers, I will try to fix the language so that in the Google Classroom we will have the English language more. The plan today is to work until 8 o'clock, not longer, so we will not make it too long, but it will be quite intensive. Cool, I see some answers going on. Again, quite uniform answers. Wow, that's interesting, nice. Some of you are more careful than others. That's great. That's great. Anyways, let's ask another question that I should have asked in the very beginning. So, how comfortable you are with Python? So, rate yourself from 1 to 10. So 1 is the not good. 10 is like the guru. So let me know, please. Okay, somebody is a little bit delayed. That's fine. So please answer a question regarding how comfortable are you with the Python, because I really need to know. Like maybe I should just skip all of the basics. So let me know. Funny, somebody is not so confident. 10, 7. Okay, 8. So we have quite confident people answering. I still need to get the answers from others. So just want to know that we are all on the same page. Like, so one person is not so confident, but many are quite confident. So that's good news for the people who are not very confident with Python. Then you probably will need to work a little bit more on your own as well. So I will go through some basics quickly, but it seems like that I should not be so focused on the basics. So I will wait for some answers more. So some of you are really confident with this one. So just a second. Okay, let's wait for a few answers more. So what we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people answered. Amir is also joining. That's cool. I know he's really good with Python. So anyway, yeah, it seems like we should not focus too much on the basics, but I'm really sad that some of you are not so familiar, but I really hope that you can catch up because the material itself is quite cool. So then let's go quickly to some other stuff. So then, of course, everything that you have here is you can have the length, so how many items are here. By the way, the fun thing is that from your answers on my small questions, I kind of got it that you already know all of this stuff. So that's a good sign, basically, so that you prove yourself first and then you say that you know the stuff. That's good. So so you have the lists with these things. Then we also have the dictionaries, so and the tuples. So the dictionary is something that you write in multiple ways. So in Python you can write things in many ways. So here you have, like, let's say some kind of key 1, and then you have some value 1. So the value 1 could be anything, you know, like you can have multiple stuff going on here. So these will be the dictionaries, and then you can access them or set them using syntax like this. So we can have some, like, we can override the value like that. So that is one thing. One thing that you also keep in mind in Python, the tabbing is super important. If you add tabs in the wrong place, everything will go really bad. Oh, nice, Ariel is joining. That's fun. That's fun. So anyway, yeah, these ones. So the dictionaries, then one thing regarding the casting. So let's start by the very simple casting. So I will maybe add some stuff here. So the casting. So if we have some variables, so variable names can be anything you wish, right? So let me double check that I'm on the correct screen. So variable 9, for example, we can type it as, let's say, 2.2, some kind of number, and then we want to cast this to the variable 9 integer type. So we can just have so we can call also this as a 10, you know, like just to keep it in the same way. The variable names are not important. You can invent them as you wish. So here, if we cast it down with integer, this would be the same as floor operation. So those of you who are quite good at the Python, well, so maybe I can show you some. Oh no, I will just. So there are quite tricks that you can use. Anyway, so this is one way. Then the other way would be variable 11. You can cast it back to the float like that, right? And with the integer, with the booleans, so variable 12, this is going to be the boolean. So with the booleans, maybe it's not that simple. So maybe there is some ways you can. So definitely you can cast the integers to the booleans. So so anything. Let me check. So this one. So anything that is not 0 is the true, and everything else is false. Okay, so that's with the basic casting, and then we go to the more advanced casting. So the more advanced casting is because we have two types of containers. So collections, containers, lists, arrays. So these are just synonyms of the same thing. So let's see, we have the variable type list, for example. This will be the first one. So this is the simple one, 1, 2, 3, whatever. Then we have variable tuple, 1, 2, 3. This is with the round brackets. With the round brackets, you must be super careful because you can write something also like this, tuple, not tuple, let's call it not tuple. So you can write it like this, and this is not going to be tuple. This is going to be arithmetical bracket, and this will make just like an integer of 1. But if you write it as tuple like this, real, it will have 1 comma like that, and this is a collection with element 1 and with a tuple type. So the tuple is something that you cannot modify later, cannot modify, but this you can modify, can modify. So the tuples are very commonly used in deep learning for describing the matrices and vectors, the sizes, ordinality, and shapes. Then the last type that we need definitely very soon, even today, is the variable NP array. So this is defined by NP array, like that. And again, you convert immediately lists to the NumPy arrays like this. You just add those list brackets and 1, 2, 3. So, and this is now the list that like the list, the array that you can have all sorts of mathematical or arithmetic operations done with it. Yeah, like, but you cannot do this with the list. You can only do this with the array. So if you do following, like for example, adding 2 to this array, so this will produce actually, it will produce 2, 4, 5, something like that, an output. But you cannot do this with the list. So if I add here +2, there's going to be error. So the syntax of plus for the list exists, but let's not do this now. So here, this will create an error, but this will work because this is a mathematical, like you can think of it as the math lab, or what else there was, the kind of like just a vector basically. So they think of this as a vector. So math vector, and this is actually the just just collection. So with a math vector, you can do a lot of things. With a collection, you can do less things. But still, you often use both, because some things like modifying this stuff is much easier than modifying this stuff. If you want to add dimensions, reduce dimensions, like just like keep count of them, all sorts of things. So the last thing missing here is how to move from one to another. And with PyTorch later that we're going to do, we constantly will move through all three of them: the list, the NumPy array, and then the tensors. So here with the NumPy array, I actually just realized that I should have asked another question. After I will do this, I will ask that question. So here, if we want to have this as a list, so var, let's say this is going to be the list, so var / list. Again, the first that I write, this is not important. You can write whatever you want here. ABC, so this is just the name of the variable. So here, the np variable we can write as toList. So this will move to np array toList. And if we do the following in the other direction, right? So if we can have the np array and pass the list in this manner. So then we have the list to np array. np array. Of course, you can do also same things with tuples and stuff like that. So for example, again, we can call it variable list2 and have the list tuple converted to the list, and then we can convert it back like tuple like this. So this is about all of the casting. So I will drop this code also in the Google Jamboard. I mean the Jamboard. Yeah. So because if somebody is not familiar with this stuff, you can catch up. But in general, I think most of you are familiar with this stuff. So this will be the slide number 5. And now let me ask the question that I forgot to ask in the beginning as well. So let's write the question here. How comfortable you are with PyTorch or TensorFlow? So that's again from, let's say, from 0, like not from 0, from 1 to 10, because I forgot to add 0 in previous question, so the consistency. So anyways, how comfortable are you with the PyTorch or TensorFlow? So, and if you're very comfortable, please list also which one of those libraries do you use, and yeah. So if you use both, you can just type in 10 both. So let me know that question as well, please, in the chat. And we'll move on to the next part very quickly. So by the way, just to let you know that the code that I'm showing you is always available on the Jamboard here. And maybe I will share the link to the Jamboard, because I think I have not shared it here in the chat as well. So if I go back here, I'm still asking for the question. Okay, so the link to the Jamboard. In general, I think it's quite cool that it seems like you are familiar with the Python, but you're not really familiar with the PyTorch or the TensorFlow. And that's a good combination, because that means that you should be able to quickly jump on the logic of this. So just a second. So I see none of you are like very much familiar from the students, I guess. So if somebody is not having the Jamboard, it is here. So I posted the Jamboard in the chat. So I see some. I hope that more people will engage with the chat. But so far, from those that have engaged, most of you say that you're not familiar that much with the with the PyTorch and stuff. So that's a good feedback, because then I know which parts to focus on more. Okay, so good. Let's move on. Okay, interesting. So Emils is saying that he done something with it. So maybe Emils can comment about the PyTorch. Okay, cool. Amir, I know. I thought Amir will give 9 or 10 with PyTorch. So anyways, but great to see him as well here. Okay. Then quickly move on to the next part. So the next part is the conditions. So Emils maybe can type in what library he feels comfortable in 7. So that would be interesting. Is it PyTorch or TensorFlow? So then conditions. So that will be the next part. So here in the Python we have very basic stuff with the conditions. So here let's see. We have some kind of variable, for example, a, or we can just, in the sense that, just write a. So a will be 2. So if a is larger than 2, then the then is with the colon like that. Then we press enter and keep the tab. So there must be a tab there. So we can then do the printing. So print. Okay, great to know about Emils. That's a promising start. So fa is 2, like that, okay, is larger than 2, larger than 2. And then we can write else if, for example, a is larger than 1. So we can write it print a is larger than 1, and then we can have else print. So I mean the f here is not necessary. A is smaller or equal than 1. So these are the if statements. Some things that need to be noticed here. So maybe we can also write here, let's say, some kind of limit, or make it anything else. And here we can add, let's say, and a is smaller than 100, for example. And here, so basically we can add multiple conditions like this. We can skip also this middle part completely, so everything would work also like this. It would also work without the else part, like this. So all of these things are just optional, and you write your conditions in this manner without using any like brackets. So do not use brackets like in other languages. And okay, what does f do with the front? Okay, so that's a good question. I like that somebody is interacting with the chat. So the f is just a formatting string literal. So you can have, if you add the f in the front, you can use the curly brackets like this and include the variables here in the string, and it will do the conversion to the string. So this would be the same way as if we would do the, let's say, normal string with just a plus sign and then converting to the string like this. So the line in 68 and 70 are basically the same, but one is much easier. So with an F, that is much easier. So I really appreciate you giving the questions. So the questions help me to guide the conversation better. Okay, so this is the if statements, or the if statements or rules, right? So then we are missing the loops. So the loops, some of the most common loops are the following. So let's have some, so the loops. So one is of course the for loop. So this is in range of something, let's say 100. So we want to have I going from it will go from 0 to 99. So I know some languages, you know, like Pascal or some really old archaic languages have different range conditions. Here they are like in normal C languages. Okay, like this one. Then we also have, let's say, the while loop. So we can use the J 1000, let's say 100, while J is larger than 0, and then we want to remove, so this would be removing 1 every loop. So, and of course inside the loop we can do all sorts of interesting things. For example, we can have if J is a modulus of 2 is 0, then we can write down the J like that. So the if statements can be inside the loops, of course. You always have to keep tabs. So remember tabbing. Okay, cool. So I add these examples also to the Jamboard. So if you don't have enough time, like actually going properly through these examples, I really highly suggest that you try to do this later with the Jamboard examples and try to write them one by one and pause the video. Yeah, so, but as many of you are really familiar with the Python, I cannot afford just sitting around really basics, but I'm going quickly through them just to try to get everybody on the same page. So this is on the Jamboard number 5 slide. We added this stuff there. So now we go to the next part, the last part before having the first actual task for you guys today is having the functions. So functions. So the programmatical functions, they're kind of similar to the mathematical, but you'll see they are so much different. So then let's see, if we have some kind of function, and then we have some parameters. So let's say param1 and param2, and then we want to do something here. So let's say if param1 is larger than param2, then let's say normally we should have some kind of temporary variable here as well. Result would be, let's say first you would do the param1, so let's see, param2 minus param1, for example. And if they are in the opposite, then we can maybe change them in a separate order. So I mean, like, it can be anything. It's just like a small example. Result. So you want to have subtraction from the larger element, you want to subtract the smaller one. So, and then to call this function would be something like this. We have a function, let's say, so 1 we can have, let's say 1 and 10, and the output of this should be then the 9. And if we pass some other function like this, the output should be again the 9, right? But if you pass the arguments directly in this manner, I suggest you never do this in this manner. Please always have the arguments also listed here. So that would be something like param1, param2, because the code must be readable. So let's say here. So please do not write like this. Do not write like this. This is much better. So this is readable. The previous line is not readable. So, and only exception when you don't have those params defined like that would be if the actual variable name that you use is the same name as the param. So here, let's say that would be like 9, and the other one we can call like 2, and then let's say we have another function call. And now, if I call it in this way, then this code is readable, and this is fine. So this is readable, and okay. Hopefully the function stuff is clear enough. There are a lot of things that I'm skipping, basically the functions can be so much more difficult. You can also use the kind of delegate type of functions and all sorts of things with the Python. With the Python, the same thing you can probably write in like dozens of ways. So that's fine. Okay, so let's go to the first proper task, because otherwise I'm like talking probably too much already. So I will open in the Jamboard, not in the Jamboard, in Google Classroom, task 1.3. So the task 1.3 is now opened, and you should implement some function there. So let me show you the task. Just a second, I will jump on it quickly. So if you go in your Google Classroom, and if maybe I will also try to share the stuff on the Jamboard. So those of you, if some of you are not on the Google Classroom and for some reason don't want to join there, at least you can see it. So here, if you go inside the classroom, so let me show you. So if you go in the classroom, you find task 1.3. So the one not so fun thing is that for the task, let's say 1.1, I only got two inputs. So if you want to finish this course, you must have to submit the tasks and the homeworks, otherwise you're gonna fail the course. So here, I now have 0 submitted, but the task that you should do now is to so let me quickly find maybe the copy image address, because this stuff is not showing. So you should implement your own function and submit the code of that function of doing the you should do the power function, right? But there are some limits. You cannot use the syntax in Python for doing powers, you know, like and you also cannot use math library, and you cannot use the numpy library. So what I want you to do is to create and submit quickly. I want to see if you are so confident with Python how well you're going to do this, is to have following. For example, if I have b powered by 3, so let me share the screen just a second. So b powered by 3, so this is going to be the task. So task create a power function, and this is, you can write it with a Python syntax like this, but you cannot submit this. If you submit this, I will not count the points for this. So this is exactly the same as you would write. The b is 2 multiplied by 2 multiplied by 2, or it is the same as if you would write as np power. I think this is the correct function. Let me check. First array. So I think there is just the more simpler one with the math. So the math, you should then import the math. So power like that, right? So 2 by 3. So and if you want to use the math, then you use import math in the top of the file. But again, you cannot use these functions. You need to write this yourself. So basically you need to write this power function yourself. So I want you to write def power a b and return the result here. And you need to do the to-do part here. So let's wait for some of you who can do this first. So cannot do this in the answer, and also you cannot do this basically you could do this in the answer if you know how to do this, because I allow you to use the multiplication, but you cannot do this one as well. So you can do this, but you need to know how to write it. So please submit the answer, and then we'll go over it, and then we'll move to the next task. So I will drop this also in the Jamboard. So this will be on the 6th slide. Especially if you were so confident with Python, I believe you should do this quite quickly. So let's see who do it first. So now nobody has yet submitted the answer. So if you are geniuses with Python, you should be able to get it done quickly. By the way, maybe I will consider not showing the answer, because in previous my experiences with the course, if I show two like trivial answers, the people just copying them and not thinking with their own brain. So you should try to struggle a little bit with such a simple tasks. So okay, let's just double check one thing. Is the task clear? And you so that maybe is the task clear? So plus, minus, and if minus, then type in what exactly is not clear about the task. Meanwhile, I will translate the next task. And you should expect with my course that I will ask you to do a lot of coding in live session, and the more you don't do the code, the more you will have to do the later, and you will also have the homework. So it's better to try to do this in the live session, at least in the capabilities that you have. I understand some of you are not as much experience in this particular language, but at least you can try. I will also count finish like the 100% for the task, even if you are not properly answered the task. But I see that you tried to do this your own. If you just like copy some code that's not yours, then definitely I will. If I catch it, you will just get zeros. Nice that I see that at least 5 people who are engaging right now are getting on this task. So we'll see who did it first. I'll check the progress. By the way, this is your first equation. Congratulations, because we will do a lot of equation implementation. I will give you equation, and then you need to implement in Python. But those equations will be much harder later. So here I see that we have first person submitted the code. I like the comment ugly but works. Okay, the code is kind of missing, unfortunately. So just to make sure that other people also don't make this mistake. So I see that the person tried to submit the code here, and he actually accidentally submitted the HTML file, and I don't see exactly. I see that there is the actual code around there, but it's very hard to read right now. So please resubmit the code in a proper way, because otherwise I cannot evaluate it. So it's great that you submitted the first one, but I cannot read it. So make sure you submit Python file, okay? Okay, meanwhile, I will keep on writing the next task. Oh, I see that he submitted now the PNG file, so that's also fine. So as long as you submit something in a readable format that would not take me a lot of time to convert, that's fine. Okay, now I see that actually Betty submitted something that was different person, but that's great anyways. So, okay, I like it. I like it, so let me check. Yes, I think that the answer of Betia is good. So that's great. I like that you were one of the first ones. Okay, somebody is not added in the Google Classroom? Okay, let me help you out. So that was the question I wanted to have earlier, but let's see. So I will get you in the classroom just in a second. I tried to get all of the people that want to join this course in the classroom, but it seems like that some of you slipped through. So here there is the Google Classroom invite. Google Classroom invite. So you can join by this link, and you should use the personal Google account. If you use the work account, they will not let you in, unfortunately. And I see from Armands there is a question: how do I add result to the task as in submit the code in Google Classroom? So as I'm the teacher here, it's hard to me to show, but I see that already 4 people have managed to do this. In the Google Classroom, when you go inside the task, in the right side, you will see like a button where you can upload the file. It can be anything like PNG, text, Python file, like, and then press submit. Or it can be even a link probably to the Google Column. So that's the way how you submit the code. And I now see already 5 people submitted the code. So these are the 5 first kind of winners. So we'll check later also the accuracy of the solutions. So the most interesting thing right now is that those of you who are telling that they are good at Python, I want to see if somebody do this using the recursion. So the recursion is one of the programming languages features that is kind of regularly used and quite powerful for the search algorithms and for all sorts of algorithms. So far, I don't see yet anyone using recursion. So recursion. So let me see. I don't see it yet. Maybe if I miss it, then let me know. I don't see it yet. So if somebody wants to resubmit it using the recursive function, then that would be great. That would show you how good programmer you are. But like, this is really dumb task, and you should be able to use recursion for this one. So far, nobody used recursion. So, but I will wait a few minutes probably. We don't have too much time, but we have some. So I see already how many people I see that are succeeding right now. 6 people, and maybe even more. Let's see. So we are seeing 6 people succeeding. That's great. But we are at least 14 people watching now. So I'm expecting some more answers. And those of you who submitted very fast ones, like the winners are right now Armands, Betia, Kristaps, Kurtz, Martins, Nix, And so you can try to resubmit this with the recursion. You can think about it a little bit and you should be able to do this. So I will not actually show the answer for the recursive function, but if somebody can come up with it, it would be great. Recursive version. For those of you who are not confident with the Python, any answer would be excellent. Okay, let me double check one thing, because I have 6 answers now. So are you still working on it? Plus, minus. So if you're done, then you can type in minus. If you are still working on it, then type in plus. If you're given up, you can also type in minus, but that would be not recommended really, because this is really a kid's game, but we will soon start working with the real guns. So the question is, are you still working on this? And then we'll move on to the next part that we need to definitely cover today in order for you to successfully do the homework that you need to submit for tomorrow. So I understand this is quite tight schedule, but this is what we have to do. And then the next session will be a week afterwards. So every Wednesday, Thursday, for about, if I remember correctly, 2 months or something. So we can have these, and we will have quite a crunch there. So I see those of you who submitted the code once saying that the minus signs, they are not trying to get the recursive function probably. So I see that Armand's probably trying to do the recursive. So I see additional people joining the winners. So the Gints also joined the winners, so that's great. I forgot to mention, we will also have at the beginnings of the sessions the scoreboard. So those of you who are active in the live sessions and the homeworks, you will get scores, and we will see who is the best of the pack. So again, I must emphasize that even if you're not a great programmer or not comfortable with all this stuff, if you try this and submit even faulty code, but I can see that you tried your best, I can also count in the points. So I will wait a few minutes more and then we'll do the last part of the session. I see that we have 8 winners now. Let's see who was the latest one joining our pack. Multiple Kristaps, Bloombergs, Kristaps Siksne, Kurts, Martins, Nix, Gints, Betty, Armands, the winners now. So let's see, I will maybe also rename the video so because with the English language is a little bit easier for me now. A lot of terms, especially not now, but later it will be definitely easier. So, okay, I didn't see many people giving me the answer regarding what they're doing now. I don't see Emil's actually, I guess, joining the Google Classroom. Hopefully he will join later. So again, I say that to join the Google Classroom, you need to use private Google account. Otherwise, they will not let you in. Okay, so let's move on slowly. So I will check later if somebody did the recursive function. That would be great. But let's do the next task. So okay, I will comment out actually. With the PyCharm, another hack is that you can use Alt or the Control command. So Control command with this sign, and if you select code and do this, you can comment out the whole block of the code immediately. So that's quite cool stuff. Okay, so Emil's okay. So sorry for that. I did not see probably the updated list. Yeah, I see you're submitted. Thank you. That's great job. Maybe I can give you somehow cookie. So cookie. Okay. Good job. Oh, Armands did it recursive. Let me check that. That sounds good. That sounds good. Let me check that one. Yeah, I like it. Yeah, let me think if it works with the minus. Okay, but most of this didn't work with that one. Okay, anyways, so in general, the great stuff. So the Armands, I think, is one of the few ones did this with recursive. So I did not specify the range of the task, but in general, what you did is great. So another cookie, maybe. So let me give another cookie. So okay, let's do the next task. So for the next task, again, we'll have quick questioning answering. So we need to do the classes. So in a Python, you write the class like this. So the class is, by the way, there is the new Python versions that simplify some of the stuff. I will write this in the way that I'm used to writing it. So here we can write it as, let's say, some name of class, right? And then we have these curly the simple round brackets. And inside here, we can either not list what kind of superclass there is, or we can list it as object if it's like a simple one. And then we have the constructor defined like this. So there are two underscores. This is very important. Again, if you use the PyCharm IDE, it will give you automatically this stuff. But there are two underscores, right? Underscores, right? And then here you can define all sorts of private or public members. So the private members you define by two lines. So this will be the private member variable. This will be the private one, and this is going to be the public one, or the attribute as well, or the property, whatever. Property actually is a little bit different, but this will be attribute. So public member, and then the functions. This could be again with the two lines or one line. This could just the function, and param, and then we can set some param, right? Like this. So this is just this quick example of the class, and then to use the class to have the instances. So this will be the instance 1 of the name class like this. And if you actually would like to pass something in the constructor, then we can have the arguments here and pass them here. So this will be instance 1 and instance 2. So like that. And if you want to call the functions for the instances, we can call them, of course, something in the manner of this, like param is something like that. So this is the way how you write some of the Pythonic way of the object-oriented classes. And so we come to the question. So what are the main principles of object-oriented programming? What are the main principles? And if you type in the answer, then try to also write in your own words what it actually means. So I'm waiting for the answer in the chat. Please interact with the chat and give me the answer. So it would help me to understand this better. Does the self? Yes, this is correct. So I like again that Armands is asking the question. So the self is exactly like that you access the internal pointer to the object. Like this is the same as in the, let's say, Java and C# and whatever you call this, and some kind of private member, right? Member. So, but my question still holds. My question still holds, so I will copy my question again. That Emil's has answered some other guy's question in the chat, so you can interact with each other. That's great. Maybe you should use the @ so we don't lose the track. So the self here is the Pythonic way. So this is unfortunately the Python is primarily functional programming language, not the object-oriented programming language, but it can be used in this way. So this is similar in JavaScript as well, actually, so that you kind of need to pass the pointer to the class as a first argument. So unfortunately, you cannot avoid that. So always for the class functions, you have it like this. For simple functions, as here in the 87th line, we don't need to do that. The simple functions, I mean the static functions, so you can have the static functions as well. So the static functions are written like this. So the static method def function static, and here we don't need the parameter, but unfortunately we cannot access the self as well. So what we can do is maybe have parameter multiplied by itself, you know. So this will be a static function, and for the static functions again, so we can probably, I think, call them directly from this thing as well, like this, right? And we can also call them like this, so just directly from the class. Okay, so I see that Martis is giving me the answer: inheritance, encapsulation, polymorphism, abstraction. So in general, like probably Wikipedia also gives similar answer, but I like that you're trying to kind of twist, because the abstraction, I think there's mainly 3 answers. So yeah, let me quickly go over these things, and then I will give you the next task, and then we'll get to the homework as well. So let me quickly. So I will just actually to answer the question, I will do the next task as well. So and then there will be the homework. So yes. So not sure about the principles, but yeah, if somebody can describe those principles a little bit, like what is inheritance, encapsulation, polymorphism, that would be great. If you do that, I will give you a cookie in the chat. So here, I will add this on the 6th slide, the class definition here, and then I will go to the next task. So I'm now opening task 1.4 in the Google Classroom. So in the Google Classroom, I just opened task 1.4, and this task contains the UML schema of class and multiple classes, and we will explore these 3 object-oriented programming principles very quickly using that example. So let me get it working. So the schema looks like this. So I just opened this task. If you do this task quickly yourself, the structure of these classes, and submit this in the Google Classroom, that's gonna be very great and you'll be a winner. But if you want to go with my code together, that's also fine. So here there is a superclass, the base class of animal, and this is the inheritance part, where you can inherit or like extend all sorts of features from the base class in the children classes, like dog and cat. That is the first part. Then the second part of encapsulation, you can see that some of the member variables have minus signs in front of them. No, this is not going to be the homework. Homework going to be more difficult. So I know that we have about, like, let's say 15 minutes time, but we will do this together, and then there's going to be homework. So encapsulation, having objects of different class with a within a class inheritance child. So the encapsulation actually means that these minus sign variables are hidden from outside. So you cannot access them directly and change, for example, how many bones have hidden the dog. This is his own memory. He knows himself only one. And cat knows how many items he is destroyed. And nobody else knows that, only he knows it, or she. So, and this is encapsulated memory inside the class. That is that idea of private variables, the encapsulation. So, and then the last thing, polymorphism, is that we don't care what kind of object do we have. We can interact using just some interfaces, and the extreme version of the interface is a pure virtual functions that you have in like C#, I mean the like C, C# and that kind of languages, I think also the Java. But in Python, you do it a little bit different way. So let me try to do this quite quickly together, and then you will have the homework for like yourself. So I will try to okay, go with the live code here. So this will be my code here. Okay, so be quite simple stuff, but so you can do it yourself or look how I do it, and I will explain it a little bit. So that will be required to do for the homework as well. So animal, so this will be the base class, and we actually can skip the object here, but let's add it actually so that it will be more clear. So like that, and then the def init. So I'll quickly check also chats time to time. So def init like that, and the member variables, at least in older Python versions that I know, you define like this. If you know a better way, then submit the homework and add the comment, and maybe I will catch up with your way, because Python is still changing the language. So here the hunger percentage that I asked you to define in the code. So let's say this will be the 50% hunger, and then there will be the functions. So the def get hunger percentage. This will be the getter. So this is the part of the encapsulation. So you don't access the variables directly. You do this with the getters and setters. So this is encapsulation. You do this with the getters, setters, or the properties, properties. Right. So this is one thing. Then we have the def eat. So the eat function. So it's written that we should decrease hunger by 10%. So self hunger minus 10%, and we could also avoid going into minus, right? So we could have, let's say, self hunger percent minimal value, I mean the maximal value of either 0 or the value that we have. So we cannot be hungry, not hungry in minus. So like that. I will check the chat. No questions, right? So we move on. So then the next one is the def sleep. So I will skip now the pure virtual one. So here we have the hours. So how many hours this animal has been sleeping, and there is a formula given there. So the hunger is increasing by 10% every hour. So we plus it by hours times 0.1, and again, let's say that hunger cannot be over the 100%. So like that. Cool stuff. And now the pure virtual function, def move. So each animal, let's say by moving, have different hunger increase or decrease. By the way, I just see that I made a small mistake in the cat. I wanted to make the cat increase the hunger by moving just by 1%, because I read somewhere that, not by 11%, but I read somewhere that cats, when they move, they are very energetically optimized, basically, so they don't spend energy, waste energy. So here we have move, and we just define it by this keyword pass. So we're not implementing this function at all. So this is actually one of the ways how we use the polymorphism. Sorry, I just misspelled it somehow. Quickly fix it. And just realized that I forgot to add the UML class in the diagram inside the Jamboard, so I will do this quickly while you catch up with my code. So if I add this as well to the Jamboard, only the one small mistake that I added is that cat should decrease the hunger increase the hunger by 1%, not by 11%. So keep in mind that. But that's trivial stuff. So I added that in the 7th slide for those of you following just on the Jamboard. Okay, so this is the one thing. So then the inheritance. So we have class a dog, and this is inherited from animal. So we copy all of the stuff from animal and use it inside the dog. So here, this is inheritance. So I will actually add these as object-oriented programming, this stuff, object-oriented programming, this stuff. So these are some of the key things. So here we again have the def init. Only I just realized that the protected variables might not be properly accessible. They are not really protected. They are private, but that doesn't matter. It's like the Python cannot really restrict you to accessing stuff. So here will be the self bones hidden, again 2 lines. So these 2 lines actually are just for the coding purposes. They are not restricting, because you can still access that stuff with the 2 lines. So here the bones hidden in the beginning, there are 0 hidden, and then def we have the move function, and now we actually do the polymorphism stuff, because here we will interact with the stuff. So unfortunately, I forgot that it don't like to do this, but we can do it. So because it will not give me the autocomplete here, because it thinks that this is a private variable. So here we decrease this by 10%. So when it's moving, we increase it by 10%, and again avoid having the I mean, not this one, but this one, avoid having the minus, like that. So this is again part of the inheritance plus polymorphism, because we can override also functions that are not pass. We can also override eat and sleep here, no problem. We can do that. This is not a limitation. So no questions still, okay? So we move on. Then we have some unique functions like bark, right? So this only dog can do. Print bark. So other animals cannot do it. So then the next class, cat, again inherited from the animal. And here here we have the so the def init self. Forgot one super important thing. Sorry, we need to initialize also the superclass like that. Actually, that's a good idea to always initialize it in the constructor. So just because I'm scrolling a little bit, I will copy this stuff into Jamboard. So the first lines with an animal code. I'm just right now copying to the Jamboard so you can catch up with the code. So that's on the 7th slide. By the way, all of this stuff is really easy, but so you should, like, if it's difficult, so you should really try to somehow catch up, because like yeah, these are just like the very basics how we speak in the language, and then we'll start doing actually the mathematics. So so this will be the then also to the Jamboard. But also don't feel bad if it's a little bit difficult. So because of course, if you're not familiar with the stuff, I understand that it might be difficult, but it depends how much you want it, you know. So then the cat, initializing it, self items destroyed. So this cat is quite fresh, he has not yet destroyed too many items. Then this one will reduce the hunger by 1%, not by 11%, sorry for that. So we can write it e minus 2, like that. And then the def meow, so it's meowing. So this is again unique function to the cat, like that. And finally, we have the robot stuff. So the robot is very different kind of animal, because it's actually not an animal. So we will not inherit it from the animal, like that. And the robot have actually the battery percentage, hopefully it's 100%. Then when the robot moves, the battery reduces by 10%, and we don't want to reduce it under 0. And we also have the function of charge, also quite unique function for the robot. And this one, this one have the hours, how many hours do we charge it. And here we use the similar idea as for the eating and hunger, because the robot do not have the hunger, at least in that manner. So minimal value of this one multiplied by hours, like that. So now we have also robot done. So I copied these codes inside the Google Jamboard, the slide number 8. So you can catch up later if you are struggling to catch up. Checking the so now Yapalil in a hunger. So let me check. Hunger. Oh yeah, this is a little, no, okay. Yeah, this is a little bit wrong stuff here. Sorry for that. Yeah, for the moving stuff, we need to, so I need to change also the Jamboard stuff. Yeah, you're right. Thank you in the chat. So let me check what else did I mess it up. So the dog I mess up, and also the cat. So we need to increase the hunger, not decrease it, of course. Of course, that is a mistake, logical mistake. So when you move, you get more hungry. So we flip the plus from minus to the plus, and they also update the Jamboard in a second. So this will be in the 7th slide, and on the 8th slide, let me double check the robot also. So when the robot is moving, so this is the opposite, because the battery is decreasing actually. So like that. Okay, great. Thank you in the chat. That is good. So let me give you a cookie. So cookie, and we are quite soon getting to the end of today's session. And then we will have also, you will have to submit this code and also the homework. So the homework will be in the direction of the game that we need to make actually, and we will work with that code tomorrow. So if you don't do the homework, it will be very hard to do the work tomorrow. So here, let me show some of the things that are missing here. So just to illustrate the polymorphism stuff and other things is that here we can have, let's say, room. So let's say who is in the room, and this will be the list, okay? So, and in this list we can append multiple objects, like for example we can append, I mean the instances basically, we can append, let's say there are 2 dogs there, so we append 1 dog, and we can append also of course in this way, dog B, and then add it like this, right? And then we can append the cat, so there will be cat, and then we can also append the robot. So the robot is the most interesting thing because it's not like inherited actually from the animal. So, and when we do the iteration over this is the, let's say the, how we could call it, entity in the room like this. So we iterate over this list. Then we can call, for example, the move function like this, and it will work for whatever object we have. So works for everybody, even if not implemented in animal, because it is not implemented in animal. Actually, it's just a pure virtual function though. Implemented, and robot is not animal, so so it works anyways. And then the other part, so this is basically polymorphism, and then we can also do the following thing: if is instance of the object entity, like the animal, so that means that this is animal entity. So we can use the eat function here, but we cannot use that for the robot. So if this is not robot, if this is not animal, so maybe this is a robot. If is instance entity a robot, then we can entity charge, for example, the robot, right? And if the instance is more specific, even more specific, like the dog, then we can bark it, right? Entity bark. So you see that we need the hours here. So for, let's say, 2 hours. So I mean, you don't care what kind of class is the object belonging to. It's like, but at the same time, you need to construct the hierarchy in a like meaningful manner. And also, for example, from the outside here, you cannot access. Let's say we can write down. So if this is actually an animal, here print f this one and get hunger percentage like that. But we cannot access directly entity and having the hunger percentage like that. So we cannot access directly, and this means this is the encapsulation. So you can do a lot of stuff with the object-oriented programming, but at the same time you have like you need to understand what you're doing basically. So you can play around with these examples and implement them yourself and submit the task. So I will quickly check if somebody did this already, and then I will briefly try to explain the homework as well. And this is going to be then the end for this session, and tomorrow we talk about this a lot more. So let me double check if somebody already submitted this homework. So I think nobody yet completed this task. Let me check. So do we have any winners now for this task? So not yet. And now I'm also opening the homework task. So the homework task is very similar to this task, but it is different because now we are actually tackling the game that we need to make. So remember I told you that we need to make the this asteroid game, right? So the asteroid game looks, so after doing the homework you should get something like this, where you have the plot with the spaceship in the middle, and this is constructed using the object-oriented UML schema that I sent you, and I give you also the template. So the template looks something like this. So the template contains to-dos, so what you need to finish, okay? And if you follow the UML schema and finish those classes and add a little bit of your own code for geometry, you will get the result that I showed you just in a second. And this is your home task. By the way, we have the first winner for the previous task, and this is the Kristaps 6 now. Congratulations. So let me give you for the Kristaps cookie. That is great stuff, and we'll see who will get the highest score for tomorrow. So that is one thing. Then let me quickly jump back to the Jamboard and set it up, some things running here. So we will quickly end in a second. So you will have time to finish the homework as well. So if I run the finished game, so this is one version of the game. It will look something like this at the end, hopefully at the end tomorrow after you do the homework. If you will be particularly slow, maybe we will do another session to do this. So you have the best students that I have seen so far. They also make that you can shoot with the spaceship, the player. So you can imagine that you can have also the object as like a missile, you know, or something like that. So this is what we're going to do using the linear algebra. So tomorrow we're going to start working on the dot products, the transformation matrices, and all of that good stuff. So I will add some of the preparation material, so it will be advantageous if you read up on that and be ready for tomorrow. So that's it for today. I hope it was fun so far. Hope it was a little bit challenging, and expect that this is going to be even more challenging in the future. But the good thing is, after this you actually will be able to do the proper deep learning models and proper AI models. So hopefully you're satisfied with what you've seen so far. Let me know if you have any comments, and that's it for today. Okay.